Okay, so now let's talk about the steps to hypothesis testing for any particular slope coefficient. We'll refer to it as the j'th coefficient for the j'th variable. And so, as usual, we'll set our beta coefficient equal to 0 for our null hypothesis and the alternative not equal to 0. So we're really just testing for significance here. And these steps are all the same as before, so I'm going to go through this rather quickly. We select our alpha. Our test statistic is the same, so it's our estimate for the coefficient b sub j divided by its corresponding standard error, and that's going to be our test statistic. And then if we want to use the critical value approach, so the only difference between this and the prior chapter is that instead of n minus 2 degrees of freedom, we have n minus k. So n minus k minus 1 degrees of freedom, where k is the number of slope coefficients. So here k would be 2. So in total, that would be n minus 3 instead of n minus 2 degrees of freedom. So same with over here. This would be n minus 3 degrees of freedom for two regression variable or two explanatory variables in the regression. So I'll just keep this highlighted to note the differences. And then the p-value approach, again, is the same. The only difference is our number of degrees of freedom. And then we give our conclusion and interpretation. Okay, I'm not spending a ton of time on this because ultimately we can just look at our regression output. We're not going to do this by hand. And then finally, our confidence interval. Same, again, we have n minus k minus 1 degrees of freedom. Other than that, it's the same as the prior chapter, which is b sub j plus or minus the critical value of t times its corresponding standard error. So let's go ahead and return to our example. So we did this in Excel, and we get this table of output from Excel. You'll see that our Excel lab is very easy for this chapter. And so we already wrote our coefficients. So let's just do some hypothesis testing and look at our confidence intervals. So let's just say property size significant. And we would say yes, because p-value, you can see the p-value for property size. Let me just highlight this. Its p-value is less than 0.001, which is less than 0.05, which is equal to alpha. So let's just we can just say alpha is 0.5. And then let's give it a 95% confidence interval, which would be from here to here. So that would be 274 to 540. So we're 95% confident that the true slope coefficient for property size and property value is 274 to 540. And notice that 0 is not in the interval, so 0 is not a plausible value for the slope coefficient. And so we would say, yes, it is significant. Now let's do the same thing for age. So age significant. We would say yes, p-value. Let me clean this up. So for age, p-value is still 0.000, so it's less than 0.001, which would be less than our alpha of 0.05, which therefore means we would reject the null hypothesis that beta is equal to 0, and therefore it is significant. And then let's do a 95% confidence interval. And here we can get our values from right here. So it would be from negative 4.2 to negative 1.4. So we are 95% confident that the slope coefficient for age is between negative 4.2 and negative 1.4. And again, 0 is not in that interval. And so that would also lead us to reject the null hypothesis that beta is equal to 0. And so in this model, we would say both property size and age are statistically significant at the alpha 0.05 level of significance.